Hey YouTube, after having a 3D printer for about 4 years, my Solid Doodle 3, it's been a workhorse. I've printed off hundreds of parts, many of which never make it into these videos because I don't have the time or energy to do them, or it's a relatively trivial project and I don't want to waste people's time on YouTube with that. But I figured I'd share a little bit of insight having recently switched to a new print bed material. Years and years ago, when the Solid Doodle 3 was brand new, it was stock, Kapton build platform. That's garbage. Ceramic tile, good for a time, I moved on. Build tack, hair-pullingly frustrating, avoid it. This wonderful material called polyether imide, I don't have it on the bench because it's actually on the printer right now running off a part. It is the best print bed material ever. Go get some. Worth your money, hands down. Good finish quality, temperature stable, mechanically robust, it just works. Okay, so if you're going to stay around and watch this video, awesome. If not, PEI, remember that. Ceramic tile. I came across this on the RepRap forums when I had retrofitted my print bed with a, a RepRap Mark II heated build platform. I used the ceramic tile because someone recommended it. You can get them relatively flat. The poor temperature conductivity means that the temperature gradient from the inside to the outside is very small. If you had aluminum, you're applying heat in the center, the outside acts like a heatsink and cools down much more than the center. That temperature gradient encourages lifting and warping of your parts. However, plastic will not stick directly to ceramic tile. So I always use this Yoo-Hoo stick glue stick. Goes on purple, dries clear, so you could tell where you had extra or where you had a thin layer that was good enough to print on. My problem was I was unnecessarily greedy. I would slap down a part, scrape it off with a putty knife, put down another part, scrape it off, rinse and repeat. So the surface finish looked very mottled. I'll get close up to the camera here. Looked pretty mottled, not cosmetically nice. But it worked. Large parts, they worked alright. Then came along this stuff called build tack. The marketing materials, which sounded nice at the time, are absolute bullshit. They claim that you print the material down, you cool this down to room temperature, and the part just pops off like that. Does not actually work. For very specific reasons. Some people have reported success and swear by it, but realistically, with moving parts in a 3D printer, things changing tolerance as they warm up and cool down, it's very hard to maintain the perfect tolerances to get this stuff to work. It's relatively expensive and it's very easy to damage. It comes as this plastic sheet with an adhesive laminated on it. You just apply it to a piece of glass. The trick to this is that the surface finish, which almost looks like it's bead blasted, seems to be the right amount of surface area to allow for a part to be printed down and not have the plastic adhere too much. But there's some catches. This material has a melting point a little above 100 degrees C. Most people start to run their build platforms between 80 to 100 degrees C, especially for ABS. The higher the temperature, generally, the better the adhesion. The problem is if you crash your print head, right, if you crash the heated nozzle, you melt the plastic and you actually kind of mix it with the print material at the time, which ends up with this area on the bed that's now ruined. Any material that sticks here to the goods area will peel off if you have the height calibrated. Right, we're talking within 10,000ths of an inch, if not tighter. Wherever the surface has been ruined by being melted in with ABS plastic, parts will stick and adhere to it permanently, and you won't be able to scrape them off. And this is the surface finish if you have a properly calibrated build tack platform. These white spots are where it actually adhered well, right? The fact that it's so gray, even though this is black ABS, is an indicator of just how rough the surface finish is. It's a very fine, rough surface. It's, again, bead blasted. So you don't see very much reflection. The albedo of this plastic is low. However, these darker areas are where it didn't stick down, and it started to lift and warp. This is an example of what happens if you have too good adhesion. If you set the height too low, all of this area here, there was a little bit of warping on this side, but this area here melted into the platform. This stuck permanently, and when you go to try and remove it, you lift and peel the whole plastic and tear it. It's a piece of garbage at that point, like the whole sheet of build tack. These parts are in white ABS. It's very hard to see the finish. See if the camera can pick it up. Very smooth, very nice parts. Cosmetically acceptable, right? Especially for a part this large, perfectly flat, right? I could take this on a granite table and it wouldn't wobble or rock back and forth. It wouldn't be, machine finish down to thousandths of an inch, but I mean, this is 3D printing, so let's be realistic. It's rapid prototyping and design iteration. Then came this stuff called PEI, or polyether imide. Now, this plastic itself has been around for a very long time. If you've ever been to a Quiznos or a buffet, you might remember seeing these little tubs of this dull amber clear plastic. That clear plastic is PEI. It is mechanically robust, as proven by the food industry. It has a wide acceptable range of temperatures between sub-zero all the way up past 200 degrees C. So they can put it in a buffet and circulate hot water underneath it to keep all the food warm, or vice versa, they circulate cold water and keep everything inside chilled or frozen. It's wonderful stuff. Only recently did someone figure out that it would work really well for 3D printing. Its surface finish from the factory as a sheet is mirror smooth. It's like glass. It's like acrylic when you peel the plastic film off. In fact, when you buy it, there's a plastic film that you peel off. Here is an example part. You can actually use this like a little bit of a mirror and bounce the light from that overhead LED light into the camera. It's that smooth. It is mirror finish, right? I mean, this is, again, 3D printing. Cosmetic quality is moderate. You're always going to have dull and layered finishes on the side walls of the part, and the top will always look like it's striated from the direction of the infill. That's kind of expected. Here's another example. I made this battery cap for Milwaukee M12 batteries that are just friction fit on, right? This won't come off in my tool bag, but that's all on a side. I'll probably post the Thingiverse file, so the STL and Thingiverse at some point when I can refine it a little bit more. Having said that, again, mirror-like finish, you just scrape it off. Now, of all these different materials, PEI wins out at the top. It's temperature stable of about 200 degrees, so if you crash the print head, it really won't mind, right? If you crash the print head and leave it there, it'll probably damage the plastic, but if you just graze the surface, or if you set it a little bit too thin, it won't mind. It'll just stick very, very well. It'll eventually come off with a good amount of scraping. Now, having said all this, if you're going to go with PEI, I'd still recommend you get the Build Tack spatula. In fact, let me go show that to you. So as shitty as this Build Tack is, this spatula is the best thing ever I've used for 3D printing in terms of removing parts. It's very hard to see the surface profile. You can kind of see it there. It's beveled from this corner here, out this way, beveled down. This tip is very fine and fairly sharp. You could actually cut yourself if you wanted to on this edge between here and here. It's very thin, but it starts to widen out towards the outside edges. You just push it underneath the part. It's ergonomic. The bottom edge is flat, so you can get it real flat up against the build platform. Push and scrape, lift, twist a little bit, and just glide this underneath your part and just kind of work your way around, scraping the part off. It's pretty easy to remove your part, and once it comes off, you're golden. This is the better investment when I was experimenting with Build Tack, because I still use this with PEI. But I'll show some insert shots of PEI in just a moment, or it might be interspersed throughout the video. Regardless, take of this what you will. Some people swear by BuildTak and are going to defend it. I really don't care. Do what you want, but I would honestly give PEI a hard look. Look at some other videos on YouTube, evaluate it for yourself, make the decision that makes sense for you. I have yet to try it with nylon, but I've tried it with ABS and PLA, and it works great. I heard mixed stories about PETG, which is a relatively new material. It tends to adhere a little too well, and people have had to resort to putting a thin layer of glue stick or other sacrificial material that will lift off of the PEI surface, but still allow adhesion between the sacrificial material and the nylon or PETG. I need to investigate it a little more before I go and print with it. But take this video what you will. If you like this video, please like, subscribe, and comment below. I'd like to hear what people have had in terms of experiences with BuildTak, with ceramic tile, and with PEI.